So today, let's take a look at where we're at on DDM. I'm going to take a look at some of the updates that have been made since I last gave an update, and I'm going to look at some of the modern tools I'm using to get away from the old-fashioned way of doing it on paper that took forever. So let's take a look. So back in the day when I was building DDM on a Commodore 64, very much like this one, I did it using a Hessmann cartridge. That was a pain in the neck. I had to do everything on paper, very carefully flowcharting everything out, writing out the code on paper, double checking it, then typing it into the computer. Once it was typed into the computer, I could print out and make notes. So this is how I did commented code back in the day on my baby little 1520 printer plotter. It was great. I've done so much on DDM since the last YouTube update that I'm going to need to split this video into two parts. So today we're going to take a look at the first part. We're going to look at things like creating character sets, creating new screens, working on the design for the combat system. It'll also include a new disk build system that's done in Visual Studio Code, but means that I get a working diskette, like this one, every time I compile. I also want to take a look at Excel and how I'm using it to create the itemization for items in the game. And while we're at it, we'll be seeing a bunch of updates that have been made to DDM, and they are pretty significant. Now, next time we're going to take a look at more of the code writing end, the tools I use for writing and compiling and actually running the game. And that'll show a whole bunch more updates that have been made. So what you're seeing today, you may get some sneak peeks, but it's not the only thing that's been done. So this is CBM Program Studio. It's a really neat little program. Actually, it's a neat big program. It does a lot of things, but I mainly use it for sprites, screen designs, and character sets. You can also do SID stuff in it, and I plan to. We actually have SID music being made as we speak. For sprites, I don't have a lot of sprites in the game right now, but this is the character you see moving around on the surface just to represent the party on the surface map. And then I've got this, which is for a selection cursor that will be used in combat. It's 4 characters in size. This is a really bad attempt at a monster that did not work out, as is this. So that's all the sprites I have right now because I haven't had a need for them yet, but they'll be coming along. I should also mention that a little later in the video, we'll take a look at pieces of the game that we're looking at in the different programs running on a native Commodore 64. Now, character sets. This is something I have used this for quite a while. And this is the original character set from Dark Dominion of Maldrakar, otherwise known as DDM back in the day. So I imported all of the data for these characters from the original character set that I made in the 80s that was drawn on graph paper and entered in numerically. So the Commodore 64 has 2 character sets. Now the one that you're used to seeing is a non-reversed uppercase. This is the default character set that comes up when the Commodore 64 is turned on. Now, when you have a cursor over a letter and that letter flashes between its inverse and its normal, it's just changing between the reversed and the regular character set. So that's a total of 256 characters, 128 regular and 128 reversed. For DDM, I don't use any reverse characters. I don't need to have a flashing cursor like that. So what I've done is I have appropriated the reverse characters to do the characters for the surface world and the dungeon. And I can come in here if I want to change this tree, and I can edit it right here, change it, re-export it, and it gets loaded at runtime into the game. Now the other character set, the uppercase character, or the non-uppercase character set, normally has lowercase characters followed by uppercase, and that's what you get when you hit, what is it, Shift Commodore or whatever, to switch to the other character set. In this case, I've actually replaced all the lowercase with the same uppercase as the uppercase character set because that's all the game uses. So that way, whether I'm in one character set or the other, the text will be fine. And that's important because this character set is for combat. If I scroll down a bit, Everywhere there's a character I knew I wouldn't need in the game, I've replaced it with this checkerboard just so I can at a glance see what's available for me to use still. And a lot of this is getting left for later because that's kind of a polish thing. Once I get all the code and everything working, I can go easily add in features. Now, in the same character set, the reverse is where I've used it a bit. These are the outlines you see when the game screen is drawn, and of course I need to have them both for combat and regular. These are oversized characters that use actually 4 characters for each one. So that's a tree, that's a rock, road, etc. This is the terrain for the combat screen. I've just made a few for testing. I'll add more later. As you can see, I got plenty of space. Now these are characters for the players. And again, each one is 4 characters to make one image. And we'll look at those when we look at the screens in a minute. So we have a couple of different characters and a monster or two. This is really convenient for me because now I can go here, I can export this, and now that DDM is saving and loading, something I probably haven't mentioned before, I can load these character sets at runtime and swap them out if I need to. Then finally, the screens. And there's 2 ways I use the screen design. One is for mock-ups. So if I load up a mock-up screen, this is the original mock-up for the menu. As you can see, there's like no map, very little on it. We'll take a look at the actual menu screen in a minute. Then this is the actual game. Everything is real. Nothing is a mock-up except this is a mock-up. But you get the idea. If you remember back a while, I was using this as an actual live screen that worked in the game. Then here is the mock-up of the character screen. And we're going to look at that in a minute in the game. This has changed quite a bit since this mock-up, but it was just to get a feel for how things would fit. This is the combat screen mock-up. So this is my original concept for a combat screen. As you can see, it looks wrong because, like I talked about a second ago, it uses the other character set. So these are those trees and rocks and things that are oversized. This just felt too cramped. Too much space here for the characters and the party, too little space for fighting. So then I tried going to a longer one using the party view that we had before. And so I wanted to block fleeing off the top and bottom, and that leaves you literally with, I think it's 5 rows of spaces. It's just not enough. And the information down here isn't necessarily the information you need to see about the selected character when you're fighting. So then I went to this. It got rid of the top and bottom row, went from 5 to 7 rows, and then showed where you could run away by just putting some callouts on the outlines. This still felt way too short. It's like you're bowling, not fighting. So then I did this. This screen, which is my current vision for combat in the game, does away with the full party being down here. When a particular character is selected with that, it'll have that outline sprite that we looked at. When that player is selected, down below here, it'll show you more information about the player than would have been visible in this, the other screen. And I'll have some keys so that you can scroll through and look at your different character stats. So if you do need to look at, see, who's injured or whatever. Then we've got a couple of spiders. Yeah, my buddy wanted to know what kind of monster that is. That's my really bad programmer art for grass. We've got a couple kinds of trees. This will look quite a bit different in the final game, but it'll work very much like this. Here's one more mock-up of a screen, in this case with a river. The river graphics got done away with. They're just going to be blue roads, basically. So this is the unused character, but you get the idea. We could have a bridge here. It gives you a nice narrow choke point for the fight. Man, I think that makes things interesting. Then here, this is the dungeon, so we got to go back to the other character set. This is the current layout of a dungeon screen, including all walls and all the possible spaces. Now, if this was the actual dungeon you were in, all you would see is these walls because it culls the ones that you can't see. But that gives you an idea of the visible area. What I want to do is go to this. So I want to rewrite the code to do 5 by 5 instead of 3 by 3. It gives you a lot more space. And I feel like then if you have rooms, the rooms can be designed to fit on the combat screen. So then combat would take place in rooms, which would then fit on this screen, and I think it all would just work really well. So that is mock-up screens. Let's take a look at the real screens that are actually used in the game. So this is the actual active menu now. We'll take a look at that running in game in a minute, but as you can see, it's trimmed down. I got rid of the fake entries. Everything's implemented except credits, which will wait until polish at the end. And there's room down here so that the little windows that pop up aren't overriding part of the menu anymore. So as you can see, we have load and save implemented. This is the actual screen that's used when you're playing the game. It looks just like the mock-up. This is the inventory screen. I'm working on inventory right now. Each of these banks holds 15 items. When you have an item selected, it'll show its details here along with its quantity and value. So all the inventory for the party except equipped items is stored on a single screen. I'm not sure how many banks you're going to get. I'm thinking of starting you with 2, and then the party shows up down here as normal. So this is very much a work in progress. This is the actual character screen, so we'll take a look at that in a minute, but when you look at the details on your character, this is all that's actually being pulled up on the screen. Everything else you'll see is done in code. And that's it for CBM Program Studio. I really like this program. I use it a lot, and I do highly recommend it. All right, so next, let's actually take a look at these screens in the game. This is running them in Vice from Visual Studio. Right now, it was loading up the data files, so when you run the game, it now, as I said, loads the sprites and loads the character sets and stuff. When I click New for a new game, you can see here, this is that screen we were looking at, and if we hit C for character, this is the new character screen. So you can see the character. In this case, this is highlighted because he's ready to level up. We've got his stats: body, mind, soul, grace, and charm, along with hit points and armor. Of course, as a warrior, he has no mana. And items are in progress, so while the character can have items in their data, it doesn't show on any screens yet or affect their stats, but that's kind of what I'm working on right now. When you're in the character screen, you can reorder the characters and then you can scroll through them. So say I don't like my paladin being in the back, so I'll go and grab Ravenna and move her up to the front of the pack. And then let's get this ranger up here. And then we got paladin, warrior, ranger, cleric, mage, thief. That should be a workable order. But yeah, as you look through, you can see the stats of the various characters. That one's got a bug in the experience. I need to fix that. But when I redid, because I've completely redone the data for the characters, that was in order to incorporate items having effects on their stats. So doing that broke the context coloring, so I need to go rewrite the context coloring. So this is manually entered data on the player. It's not being set in code, but that just needs to go back in. So if we go back to the menu now, we can go down and I can hit S for save, and it takes a minute. So after we move around, we can save. This is running at the speed of a 1541, and the game is saved. Now I can start a new game. We're back here, we're back to the default player order, but if I go in the menu and do a load, as you can see, we're back to the order we'd set. We're back to the position. Loading and saving works fine on the surface and in the dungeon. The only thing I haven't implemented yet is I need to save the text. Like if you have any text in this screen, then that's not being saved, but that should be pretty trivial to add in. So as I was working through the combat system, I came to the conclusion that now that I have a really good idea how I want to implement it and what it's going to look like, that I need to get the underlying systems that it relies on in before I actually code the combat. So that's been set aside. I actually have some combat code in there. I have a Bresenham's line drawing algorithm in that'll be useful for line of sight and for targeting. But I really need to get the items in so that the players have an inventory and that those items can affect combat, and so that people have things to use in combat other than just, swinging their fists. So that will be coming up in the future. So next, let's take a look at a program that I use to organize and figure out how all the systems in the game are going to work and interrelate with each other. And that's Draw.io. This replaces these old hand-drawn flowcharts, and I actually got flowchart paper and started hand-drawing them here back probably January or February again. And oh my God, it was just a nightmare because you need to insert and add things when you're flowcharting, and I just, that was the way it was back in the day. So what I want to do here is take a look. I made a really simple flowchart here just for you guys. This is way too simple to need a flowchart, but it seemed like a good example. I'm currently working on player effects. It kind of ties into the inventory stuff. So to heal the player, what do we need to do? We need to know what the target character is and the amount to heal. The target character is just a pointer to the beginning of the data of the character that's being healed. It takes that player's current hit points and adds the value in the accumulator to it. It makes sure that it hasn't healed over the player's maximum hit points. So if it's over the maximum hit points, then it sets the current hit points to the maximum. And then finally, if it's not over, it's done. So anyway, it's just so simple to heal a character. This definitely doesn't need a flowchart, but it seemed like a good example. Then I'm doing healing potions, and the way I'm trying to do them, and this is not a promise, but it's an idea. So rather than to have multiple healing potions, each one using up a slot, because the game can only have 256 items the way I've got it done. I can't find a way to have any more because every item has to be available all the time. And we'll talk about that in a minute because the next part's on items. So for a healing potion, it needs to know who's being healed. So the player will be healed 1 die 3 right away, and then it'll be healed 1 hit point per turn for basically 4 to 6 turns. Then, and that's my philosophy with healing potions. I don't like healing potions to be massively spammable where you just heal the full amount each time. So by doing it this way, if you want to spam them, you're going to get that 1 die 3. But if you spam them, you're going to lose the regen. So you have to wait a few turns before you regen again. So, and then my idea is that both the 1 die 3 and the hit points per turn and the number of turns, these items, these values, that there will be unlocks in the game to improve them. So your same healing potions that you always collect get better as time goes on. But that's just to show a really simple flow chart, just to give you guys an idea. This program is really handy for just managing the flow of the program. And a really great example here is this is the main game loop. And things in green are fully implemented. Things that are not in green are not fully implemented yet. But if you want to pause and look at this, this is the main game loop. So next, let's take a look at a few things I've been doing in Excel. And a while back, I showed in a video how I use Excel to design the map. And this map, as you can see, is 2 by 2 chunks. The map, when it's done, is going to be 8 by 8 chunks, so quite a bit larger than this. And then this is the key presses. What does what? And it's one of the things on my notes is I need to go update this and make some changes. But if you're on the menu, outside, inside, on the character screen, in the combat screen, if you're leveling up, all these things, I need to know what every button on the keyboard's going to do. And then this is just where I keep track of character sets, no biggie. But here is the new item database. And this is something completely new. Just added recently, but we're looking at it now because it's data related. So there's a whole bunch that was done before this that we'll look at in the next video. So we're not really sequential here. But I've got flags for what slot the items go in, a bunch of flags for things like is it droppable, is it sellable, kinds of ammunition, that kind of thing. Usability, so who can use it, what classes can use it. the maximum stack size. So obviously, hats and armor and stuff don't stack, but then, ammo stacks, gems stack, so that type of thing. We'll look at this in a second, but these are two 2-byte pointers to the words that are the name of the item. So if you have, a bronze longsword, then this pointer here will point to bronze and this will point to longsword, because literally bronze longsword would take more than half the available bytes for an item and it just wouldn't work. Then this is a parameter. So I won't get too much into this, but different kinds of items, armor, weapons, ammo, miscellaneous, they use these parameters differently, which is why they're not really named. For example, on an armor item, the first parameter is the first stat that the item buffs, and the 61st byte in a character's data is the armor class stat, and it adds 2 to it. Then the next parameter on an armor item is just a second stat that can be buffed, or 255 if it doesn't buff anything. So this could say be a item of strength, and that could be pointing to strength and the amount. Parameter 5 is currently unused for armor, but this is all fairly new. And then the final last 3 bytes are the platinum, gold, and silver value. So the whole idea here is each item uses 16 bytes. 16 bytes times 256 items is 4K of RAM. So I'm using literally exactly one of these blocks of RAM to keep my item database. And the problem with items is that if I have an item that's a tattered hat, literally the player could pick it up on day 1 and go, oh, I love this hat. It reminds me of my favorite hat. I'm going to keep it forever. And they could keep it through the entire game. So unless I want to put some kind of a inciting event where the player loses certain items, get thrown in prison, when you come back out, you only get certain things back, that kind of thing. Unless I want to do that, every single item has to be available for the entire game. So this is the item data that I've put in, and it doesn't automatically import it from the spreadsheet. So then I have the items. So we have the armor, the stack size, etc. You guys get the idea. But items are going in. The code's not all in there yet, so I can't show them on the character yet, but it's happening. So yeah, here it is. The game now runs on native, and we can load up the actual disk image that was output by the compiler. I'm having a little bit of a sparkle problem, but that I'm not sure. It's something to do with my capture in this new computer, because it doesn't do it at all on the 1702. So I'll load the game up off of the disk, and I'm going to fast forward the loading. This machine does not have Jiffy DOS, so it takes quite a while to load. It's loading a huge chunk of RAM, massive. I think this file on the disk is, 176 blocks. Each block is 254 bytes. So yeah, that's 44K, or about 3/4 of a Commodore 64's memory. I don't expect to be loading this giant chunk of RAM in the future, but for now, this is the way it's working. Okay, and once it's done loading, we type run. This glitchy looking screen is because as soon as I load the game, I move the screen RAM, but I haven't set up a loading screen in it yet. So I'll be fixing that in the polish phase. It'll just be a matter of showing loading. All it's loading here is it loads the character sets, then the sprites and the screens. It changes the border color as it loads each file so you can see that it's progressing. And then you get to the main menu like a real game. And you hit new and the game runs. And here we have the exact same thing we were just looking at in Visual Studio Code running on a native machine. Loading and saving works, and in this case, I'm even loading a game that was saved during a session yesterday, so we actually have multi-session gaming. I am going to show a little bit about the itemization and the disk stuff in the next video. This video is just too long, so I'm going to pull that aside. I hope you enjoyed this video, and I'll put up a playlist here of other videos updating about DDM so you can see what the progress has been over time if you haven't seen it before. Thanks for coming.